Okay. Hello, everybody. I want you to look at this because this will tell you what we're doing today.
I like the title.
Oh, everything you never wanted to know about quadratic functions. Yes, yes, it's a little bit sacrilegious for my field. This is in Module 8, where you can get to it. It has all the formulas you need, like the quadratic formula that we're going to talk about today. And this formula that you may not have seen yet, actually we did talk about it a little bit. And we're going to be talking about things that are not entirely new to you, but maybe with kinds of equations that are very new to you. Okay, so I wanted to show you this sheet and hope you print it off for yourself. It'll really help you. Okay, I'm gonna get rid of that. I'm not gonna get rid of it. We are going to answer these questions, but we're going to answer them with particular equations. Okay, so I'm going to need blank paper for that, and I'm going to need your homework. There. Okay, now, let's start here, because I believe one of these problems is going to be on your final exam. I don't always know what's going to be on the final exam because I don't write all of it. Especially for your class, 2 other people are involved with writing your final exam as well. The person in charge of college algebra and the person in charge of intermediate algebra. So 10 of the questions, 10 of the 25 questions on the final exam are made by other people. And I don't even get to know ahead of time what they are. All right, so let's do this. First, I want to make sure I have the kind of questions that you need. Yeah, I want to go on to, oh, come on, don't do that. Something else. Oh, all right, these are alike, but what the heck? Let us do this. We've got f of x equals x to the 4th minus 15x squared plus 54. Now, if you can see the page from here, you realize it's already set equal to 0. But what I want to do is, gosh, I wish I could do 2 of these at once, but I can't, so wishing isn't worth a lot. What we're doing is we're treating this as the quadratic function it is. And the first thing we're going to do is we're going to be finding the intercepts. We're going to find out everything there is to know about this, including solving a quadratic equation. But how can I solve a quadratic equation when it's a quartic? That's what we're going to be talking about too. Okay, first thing is I want to find the y-intercept. This is so easy. It's as easy as falling off your chair, or easier. All you have to do is let all of the x's equal 0. 0 to the fourth, oops, squared, minus 15x squared, plus, up, but that's going to be 0 squared, plus 54. And 0 plus 0 plus 54 is 54. Well, this is 54 on the y-axis, which makes it the y-intercept. And the way you write the y-intercept is you take the 0 from there and put it here, and the 54 from here and put it there. This is your y-intercept. Now, for most things you would graph in my math lab, that's way too large to use. Nonetheless, it is the y-intercept. Okay, now, we need to find the x-intercepts, and they can be difficult. Not always, but they can be. Okay, usually there are 2 for quadratic, so I'm saying intercepts, but there might only be 1. So you just have to play it by ear. Well, the first thing you do when you're finding x-intercepts is you find the zeros of the function. So just go off willy-nilly finding the x-intercepts. We're going to find the zeros of the function, which is what we did some of yesterday. Okay. So here's how we do that. Instead of, and we did this yesterday too, instead of f of x equals this, we let f of x, which is y, equals 0, because the zeros live on the x-axis. On the x-axis, y equals 0. So I'm going to say 0 equals x to the fourth minus 15x squared plus 54. Now, this is not a quadratic, so we're stuck in our tracks until we use u substitution, because notice that this is a trinomial with 1, 2, 3 terms. The problem is it's not quadratic, but the leading power, the degree, is 2 times the middle power, the middle exponent. 4 is 2 times 2. When you have a situation like that, you can use U substitution, which is a pretty handy dandy form, substitution. And what we do is we let U equal the x squared. And when we do that, then U squared is going to equal x squared squared, which is x to the fourth. When you have a base raised to a power again, you multiply the powers. So that's 4. 2 times 2 is 4. Now, u to the fourth can be u squared times 15u plus 54. Now this is easily factorable, but they aren't all. So let's just do quick factoring. 54 equals 9 times 6, and it also equals -9 times -6. And when you add -9 plus -6, you get -15, which is your B number, the coefficient of the middle term. Cool. I get to do the easier form of grouping when there's a 1 in front of the quadratic term. So U, and -9 and -6, which turn into minus signs. Now I set each factor equal to 0 and solve for U. All right, add 9 to both sides. -9 plus 9 is 0, leaving me with U on the left and 9 on the right. Same method over here, add 6 to both sides. Because -6 plus 6 is 0, and I'll have U equals +6. Now, I am in danger of feeling like I'm done, but I'm not. Because remember, the original letter that we were using, variable that we were using, was an X. You have to go back to X, and U equals X squared. Now, we got introduced to this yesterday as well, the square root principle. Okay, if I'm stuck with an equation like this, x squared equals 9, there's a temptation to say, well, x equals 3, that's half right. Okay, take the square root of both sides and put a plus or minus in front of the radical that goes over the constant. That will leave me with x equals plus or minus 3. X equals 2 numbers. It's also true that -3 times -3 equals positive 9. So 9 really has 2 square roots. The positive square root, which is called the principal square root, and the negative square root, which is called the negative square root. We're going to do the same thing here. X squared equals 6. Take the square root of both sides and put a plus or minus in front of that term. So X equals, hold your horses. This will not reduce. If we're looking for exact answers, you've got to go with just the radical. So X actually equals 4 things. 4 numbers. Bad of me. Your zeros are. That's what I need to say. Well, X equals -3, +3, negative the square root of 6, and positive the square root of 6. That's what X equals. And in particular, that's what X equals when you set Y equal to 0. So these are the zeros of the function f of x equals x to the fourth minus 15x squared plus 54. The zeros of the function, zeros of f of x. -3, 3, negative the square root of 6, and the square root of 6. There have to be 4 zeros, because the degree of the polynomial is 4. Whatever the highest degree is, that's how many zeros you're going to have. But these zeros are called real because they're real numbers. Rational because they're rational numbers. Zeros. These numbers are real numbers. They're in the real number system. Don't you wish they weren't? But they are. But they are irrational. They have decimal expansions that go on forever, and they can never, ever be turned into a fraction, which is what irrational means in math. Real, irrational zeros. But they're all real numbers. That is, they're all in the real number system, which means they all can be found on the x-axis. Although it's kind of hard to find this exactly, you can find where it is about. And they are on the x-axis, which is where the real numbers are. They're on the y-axis too, but forget about that for now, because we're talking about zeros, and zeros live on the x-axis. Well, zeros do more than that. Zeros, my cat just came in. Zeros do more than just live on the x-axis. Zeros form x-intercepts. Real zeros form x-intercepts. So since these are all real numbers, we're going to have 4 x-intercepts. -3, 0, 3, 0, negative the square root of 6, 0, and the square root of 6, 0. Okay. Now something else, and this is going to be new to you probably. We have talked about it a little bit before, but you didn't have any homework questions on it. Well, that ends soon. Soon. That ends after fall break on Wednesday. Here's the new question to answer. Or it's not, it's an instruction to follow. The instruction is write f of x in factored form. Write f of x in factored form. Now remember that f of x equals x to the fourth minus 15x squared plus 54. How do you write that in factored form? Here's how. There is a formula that you need to memorize for writing polynomials in factored form. F of x equals A, the leading coefficient, the number in front of the highest degree term. A times x minus z1, the first zero, times x minus z2, the second zero. Don't put a comma there, silly girl, you are multiplying. Okay, silly old lady, whatever. X minus z3 and x minus z4. And if you're telling me you don't know what the heck x is, and you certainly don't know what all those z's are, here's what they are. You can choose. Z1 equals Z2 equals Z3 equals Z4 equals. While we're at it, you need to know A. A equals. We know what A is right now. We can go figure it out. The number in front of the leading term is an invisible 1. So, problem solved. That's A. A is 1. Now, no matter what your order is, let's go to the list of zeros right up here. And we can just say -3, 3, negative the square root of 6, and the square root of 6. And then we substitute all of that in the factor formula. F of x equals 1 times x minus -3 times x minus +3 times x minus negative the square root of 6 times x minus positive the square root of 6. And once I have all that written down, I'm going to go back and clean it up. F of x equals, when 1 is multiplied by something, it becomes invisible. So we're going to let it be invisible. Minus minus is plus, so this will be x plus 3 times x minus 3 times x plus the square root of 6 times x minus the square root of 6. And now let me see if I left anything out. While you think about this, I am going to go get this sheet of paper. Oh, it's over here. Here. And I'm going to answer these. So my f of x, then I'm going to be erasing it and using it over and over again. But if you print out several sheets, you can use this with all your homework, especially what comes next week. Because there'll be more. It's almost Halloween. And the Day of the Dead. Viva la vida. Okay. Or boo, depending on what your nationality is. Boo. Okay, where was I? Yes, okay, well, our function is x to the fourth minus 15x squared plus 54. We didn't answer one of the most important questions about A, which is number 1. Okay, A is 1. And it's number 1. Is this going to be cupped up or cupped down? Well, think about your end behavior. The highest degree is even, and the leading term is positive. That is, the leading coefficient is positive. So this is going to be out at positive and negative infinity, cupped up. Okay, the y-intercept, right, is an ordered pair. That was 0, 54. And the types of zeros. Well, they were real rational and real irrational. And there weren't 1 or 2, which is what you usually get. But no, this was a quartic, so there were 4 zeros. And we didn't have to use the quadratic formula. We used factoring, and that's okay. It's much faster than using the quadratic formula, but we're going to use it today. Factoring, we solved it by factoring. I've got my letters all spaced out there, but -3 and 3 and negative the square root of 6 and the square root of 6. Those were the zeros. Now it says to write the quadratic function in factored form, and we did that. And after it was all cleaned up, we had x plus 3 times x minus 3 times x plus the square root of 6 times x minus the square root of 6. And write the x-intercepts as ordered pairs. And here's an example. Again, this sheet is really for quadratics, and we solved a quartic. So there would also be z3, comma 0, and z4, comma 0. And so those would have been -3, comma 0, 3, comma 0, negative the square root of 6, comma 0, the square root of 6, comma 0. And when you answer this kind of thing in my math lab, you have to put commas, commas, commas in between. And then, did I leave that up there? I left it up there. I thought I moved it. I must have copied and pasted. Oh well. Still, real rational and real irrational, and there were 4 zeros. And that, you will find, is all the first stuff you usually have to answer about any quadratic formula. Any quadratic formula, any quadratic function, excuse me, or here a quartic function. They're very similar. The leading terms have an even degree, and the leading terms are positive. So one way or another, the quartic eventually gets cupped up. In your first homework, the one you do tonight, the one that you want to do before fall break, because who's going to work during fall break? But I'll be here. I decided that I would hold class, not class for you that you have to be in, but just I will just be here with the class on, and anybody, you can come and hang out, you can come and ask me questions, any homework all the way back to the beginning of the semester. Because I'm not going out of town. I am going out to dinner much later, but not at 10:30 in the morning. So I'm going to be here during class time on Monday and Tuesday, even though you don't have to be. It's fall break. You're supposed to be playing. All right, enough of that, enough of advertising. Let's find another problem. So, wait. Right. Okay. Yeah, I filled this full of Quartics because I do know it's going to be on the final exam. So I am going to be moving along and I'll get some equations from elsewhere, but you're going to have lots of practice. You will not have any reason, ooh, this is what I wanted. Maybe I'll do it again. Ooh, okay, I will. Now I'm happy. I am really happy because you need to see that in real life there are complex conjugate zeros that you get. Okay? So, let's do this thing. I'm going to go back and get my blank paper. Oh, I just saved it. What a stupid thing to do. Oh, well. Let's go to the next page. And our function is going to be, I'm going to pretend those are X's, okay? Really, the letter's going to be Y, but I don't want to say f of Y. So, f of X equals X to the fourth plus 2X squared minus 3. Make sure I copied it right, except for the letters, of course. Okay. Now that's the original function. And you're being asked basically to find the x-intercepts, to find the zeros, I'm sorry. You're being asked to find the zeros. It's already set equal to 0, so you don't, for the homework, you don't have to find anything else. But I want to tell you the broader story, and it will help you have to learn less new material after fall break, which again will be next Wednesday. Okay, I'm still but remember the first question is this cupped up or cupped down? 1. This is cupped up. Out on the ends. Okay, because it's a quartic and not a quadratic. But out on the ends, it definitely is going to be cupped up. Now, 2, why? I should say why again first in case anybody missed it. All right, the leading term is of even degree. 4 is an even number. Even means 2 goes into it evenly. So the leading term is of even degree. And the leading coefficient is positive. What leading coefficient? This invisible +1 right there. The leading coefficient is positive. For those two reasons, coefficient. That means work together in Latin. Might mean the same thing in Greek, I don't know. Leading coefficient is positive. So when you have these two things working together, you're going to have a cupped up on the ends polynomial. Okay, 2. What is the y-intercept? The y-intercept for any polynomial, and in fact for just about anything, any function, for any function, is going to be f of 0. You let all the x's equal 0. Up 0. And what you end up with is -3. So the y-intercept is going to be the point. The x-coordinate is 0 because you let all the x's equal 0. And the answer you got was -3. That's -3 on the y-axis. It's always good to be able to find the y-intercept. You can easily graph that if you were asked to. Okay, now 3. We need to find the zeros. And we could factor initially, again, because -3 breaks down into +1 times -3, and +3 times -1, and +3 plus -1 is is +2. So yeah, it would be easy to factor just like the other one was, but we have to use the quadratic formula at some point. And so we're going to do that. But first, we have to use U substitution to make it quadratic. So U equals x squared, and U squared equals x to the 4th. I showed you how that happens in the previous problem. So f of u is going to equal u squared plus 2u minus 3. Oh, that's so quick and easy to factor. All right, let's just do it. 0. You have to put a 0 there if you're looking for the zeros. 0 equals u squared plus 2u minus 3. So 0 equals 2 empty parentheses. U plus 3 minus 1. Because -3 equals 3 times -1, and 3 plus -1 equals +2, which is the B number. Then you set each of these equal to 0 like we did before. U plus 3 equals 0. And U minus 1 equals 0. So U equals -3 and U equals +1. Beautiful, but we're not done. Because the original function had x's, I decided to call them x. We now are going to have to resubstitute what U really equals, and that's x squared. So we're going to have x squared equals -3 and x squared equals +1. And I will then use the square root principle to solve these. Take the square root of both sides equals plus or minus the square root of -3. And the square root of x squared equals plus or minus the square root of 1. So x equals plus or minus, are you ready? I times the square root of 3. Well, over here, these are going to be nice. X equals plus or minus 1, positive or -1. So now, you have 4 zeros. You've got negative I times the square root of 3, positive I times the square root of 3, -1, and +1. These complex numbers that live in the complex number system, we talked about that on Monday. These are complex dash conjugate zeros. While these are real, rational zeros. Pretty cool. Now there's something else that you may find interesting. I think it's incredibly interesting. These guys do not make x-intercepts. Complex numbers don't live on the x-axis. Only real numbers, the real rational and the real irrational, live on the x-axis. Complex conjugate have their own kind of dimension. And I drew a picture yesterday that wasn't so great. Okay, these do, however, they're real numbers. These will make x-intercepts. Do make x-intercepts. Intercepts. So let's write the x-intercepts. -1, 0, and 1, 0. And then let's number our zeros. So Z1 equals -I times the square root of 3. Z2 equals I times the square root of 3. Z3 equals -1. And Z4 equals +1. And A, if you recall, is 1. The leading coefficient is +1. So when let's move over here. When we use the factor formula, times x minus C1 times x minus C2 times x minus C3 times x minus C4. We will have an invisible 1, x minus -I times the square root of 3, x minus I positive I times the square root of 3, x minus -1, and x minus +1. See how you have to have the x minus in there? You can't just throw it away. And that will give us, this minus will give us a plus, x plus I times the square root of 3, x plus, x minus. There's no minus there. It's just one minus sign. So it's a minus. X minus I times the square root of 3. X minus is plus 1. And x minus 1. And that's what f of x equals. You could multiply all these back together if you cared to, and you would get f of x equals x to the 4th plus 2x squared minus 3. Okay, now we are going to move on to where there are some more grown-up quadratic functions. I had no intention of working on quartics all day. Yes, good. Okay. Now, what I want to do, you don't have to do this now, this is for next Wednesday. There. Wait, I need to check out the answers. Don't you wish you had that? All right, these are real but this is the vertex. I have no idea what the x-intercepts are going to be. However, I can look at the graph. Let me tell you how I'm doing this. If you have x-intercepts, that means you're going to have real or irrational zeros. And here they're very rational. All of these, those could be, look at this. They're probably fraction zeros. Don't look over here because those aren't, that's about the vertex, the location of this point. But down here, those could be fractions or they could be irrational numbers. There's no way to tell just from looking. I am unhappy. There, finally, we have a quadratic function that does not get anywhere near the x-axis. This has complex conjugate zeros. There are no x-intercepts at all. That means the zeros of the function are not making x-intercepts, which means the zeros of the function are not real numbers. Because if they were real, they would touch the x-axis. So we are going to have fun with this one. And that's all we'll probably have time for today. See, I had a list, but now I couldn't find it. And that's why I'm having to actually go look for it. True confession, f of x equals, let's say -1 x squared minus 8x minus 18. So that a is -1, b is -8, and c is -18. I can promise you, absolutely, that that is not factorable by any means you learned earlier in the semester. For this, we use, you have to use the quadratic formula. So we're going to. And here is, this is a quadratic, so I can legally use the quadratic formula. It can be used with any quadratic function that is set equal to 0. So since we need to find the zeros, let's do that. 0 equals -1 x squared minus 8x minus 18. Now here it is, and there's a little song. Yes, here we go. X equals -b. Oh, let me write it. X equals -b plus or minus the square root of b squared minus 4ac all over 2a. You need to sing that to yourself every night. And if you have children, sing it to your children. Warp their minds early. All right, here we have A. I'm going to plug that in there. Here we have B. I'm going to plug it in there with parentheses because it's negative. And C, I'm going to plug in for C with parentheses because it's negative. So X equals negative the B number, and the B number is -8, plus or minus the square root of parentheses -8 squared minus 4 times -1 times -18. Over 2 times -1. How about that? Okay, X equals positive 8 plus or minus the square root of 64. Negative 4 times negative 1 is going to be plus 4 times negative 18. And positive 4 times negative 18 is going to be negative 72. Over negative 2. Look at that. I made that way too long. I didn't have to. I could have come over here. I can do it anyway. 8 plus or minus. Now, 64 minus 72. You know, I could have done it in the time it took to do this. That's what you think to yourself. 64 minus 72 is negative 8. Make sure I'm right on that, people. Yes, I am. Okay. Over negative 2. So x equals 8 plus or minus over negative 2, the square root of negative 1 times 4 times 2. That's called simplifying a radical, and we talked about that when we talked about radicals. It's not fun, but you gotta do it. 8 plus or minus the square root of negative 1. I'm doing this the long way. The square root of 4, the square root of 2 over negative 2. That's going to be 8. Let me pull this up, roll it up. Plus or minus. The square root of negative 1 is I. The square root of 4 is 2. And then times negative 2, which will not simplify. All over negative 2. And then finally, x equals, all right, now you have to do this with I numbers. I numbers are complex numbers, and that's the way math is done in the complex number system. 8 over negative 2 plus or minus 2 that times the square root of 2 over negative 2. Bring the I out to the end. This is called A plus BI form. X equals negative 4 plus or minus. Negative 2 goes into 2, negative 1 times. Okay, so we actually need to keep working these out a little bit. This is called A plus BI form, only here you have A plus or minus BI. These are not the same as the AB up here. Completely different numbers. Whoever was working with this and named those wasn't thinking about this. which is kind of annoying. I wish they would have chosen different letters, but it's the way it is. Okay, now X is going to equal two numbers because of that plus minus. X equals negative 4 plus negative 1 times the square root of 2i. And X equals negative 4 minus negative 1 times the square root of 2i. And so I'm still busy prettying this up. X equals negative 4 plus minus is minus, so minus the square root of 2i. And X equals negative 4 minus minus is plus the square root of 2i. These are complex conjugate zeros. Now, there are no x-intercepts, but there are complex conjugate zeros. And look up here. A is negative 1. So I can write this f of x, the original f of x, I can write in factored form. Equals, well, let's write the formula. A times x minus z1 times x minus z2. I only have to go to z2 because there are only two zeros and because the degree of the polynomial is 2, which means there can be only two zeros. So f of x equals negative 1 times x minus parentheses negative 4 minus the square root of 2i. And yes, I guess I should have used brackets there. Times x minus z2. I'm letting this be z1. And this be z2. See, it doesn't matter. I'm just going left to right. All right, so negative 4 minus the square root of 2i and x minus parentheses negative 4 plus the square root of 2i. So, no, we're not going to say negative 1, we're just going to say negative. Negative, here's your answer if you're putting this in factored form. We're going to distribute that negative sign, so this is going to be x plus 4 plus the square root of 2i. X plus 4 minus the square root of 2i. And that is this in factored form if we were finding the zeros and the x-intercepts. But there is a y-intercept right here. That's the number you get when you let the x's equal 0. Shh, okay, all right. All right, come on, come on. She doesn't like me giving you attention. I just thought I'd tell you. My cat is meowing. and refusing to get up in my lap. She's teaching me a lesson. Here's the ending to this problem. Hello. What is the ending? What was I even saying? Oh, the y-intercept. If you needed it, the y-intercept is 0, -18. And what else? Oh, because there's a negative sign in front of the x squared, this is a cup down parabola. And what else? Is there anything else to talk about here? There might be. Oh, there are definitely no x-intercepts, and here's the graph right there. There are no x-intercepts because the two zeros are complex conjugate. That's the reason. So see, it can get a little difficult there. But you're tough enough and you can carry it out. Next week, we analyze quadratic functions, but this week there's one more day to go, and what we're going to do is solve word problems that have to do with solving quadratic equations. There are two that I know of that are there, and if we have a whole lot of time left over, well, we might as well just start with analyzing quadratic functions. So hang around if you have questions. If not, I'll see you tomorrow. And gee, don't waste your extra 6 minutes getting out early. Yeah, 6 minutes, 6 whole minutes. Ooh, you can take a restroom break. Talk to you later. Bye-bye.
Bye, Miss Barbara. Have a nice day.
You too.